Okay.
to get an entrance.
We're on.
Yeah, so this is a basic hive setup. So you've got your bottom board, you've then got a brood box. In here is a thin metal mesh, which is called a queen excluder. And then anything above the queen excluder, any box above the queen excluder is classified as a honey super. And then you've got a lid and then frames inside here. So the bees come in through the entrance here and then they walk up. If they've got pollen, they'll deposit the pollen in the brood box where the queen is. If they've got honey, they go up through the queen excluder into the honey super and then they vomit the nectar, because honey is bee vomit essentially, into the honey supers. So underneath the lid, we've got an inner hive mat, so we put that on the top just to stop the bees from building wax comb from the frames onto the lid, so that when you open it, it's not all stuck. Then you've got your frames. Now these are undrawn, so the bees would draw the comb out from on either side of these frames here. So this would be where all your honey is, and this is what we would bring back on the pallets to put through the extracting room. This would just be honey. This is the queen excluder. So the openings in this mesh here are big enough for the worker bees to go through, but the queen is a lot bigger. So she can't actually get up through these gaps. So what that does is that keeps her in the brood box with all the baby bees and gives her space to lay her eggs into, so that when we come to take these supers off, what we do is we just tip the box up on its side and we just use a blower vac and blow the bees that are still in this box out, and then they just go back into the entrance. So then we can bring our boxes back here with full of honey, but no bees. The important thing is if we did that and the queen was in here, she wouldn't know how to find her way back into this hive because she's not out foraging and she hasn't orientated to that position. Once she's taken her mating flight, she never leaves the hive again, unless they're going to swarm. But she will use the other bees to help her navigate to wherever their new hive is.
How does she get in the box in the first place?
So she takes one mating flight. So she'll actually hatch, she'll remain in the hive for about 2 or 3 days, and then she'll take mating flights and she'll mate with about 50 male bees on that mating flight. She'll store all that semen and then she'll come back into the brood box, and then she'll use that stored semen to lay about 2,000 to 2,500 eggs, fertilised eggs a day for the rest of her life. So beyond that, she never leaves here.
Not a bad producer.
Yeah. So that's basically the setup of your average hive, or production hive. Yeah, it's quite straightforward, I think.
It's interesting.
Yeah, it is very interesting. And look, there's the level of nuances in our industry and the different ways to manipulate a hive and get it to do different things. In Western Australia, we have one of the world's longest queen breeding programs, continuously running. So we do all of our queen breeding on Rottnest Island because it's 15 kilometres from the coast, and there's no, what we refer to in industry as feral bee populations there, so we can really control the genetics of the bees on that island. So we actually actively breed for specific traits, so like docility, production, hygiene, disease resistance. And now what we're doing is, because Western Australia has some of the healthiest honeybees in the world, we're exporting our bees and our queens to the rest of the world, who have been crippled by things like the varroa mite, and they can't keep up with the replacement of these diseased hives. So we actually, in Western Australia, are playing a significant role in keeping other beekeeping industries and subsequently other agricultural industries overseas afloat. Because without our bees, they don't have the ability to breed up enough bees to sustain their agricultural systems, which of course impacts upon our food security globally.